In this lesson, we will build a functional traffic light using an Arduino Uno, a breadboard, and 3 LEDs. We will learn how digital pins, high and LOW signals, wait commands, and loops control the lights in our circuit. By the end of this lesson, you will be able to connect 3 LEDs, assign them to pins, and create a timed sequence. You will also learn to test the circuit and fix common wiring or coding problems that might arise during the build. You need 1 Arduino Uno, 1 breadboard, 3 colored LEDs, connecting wires, and access to Tinkercad Circuits. For a physical circuit, remember to use one 220 or 330 ohm resistor with each LED to protect them from damage. Digital pin 4 will control the red LED, pin 3 will control orange, and pin 2 will control the green light. All negative LED connections will return to the ground pin. Keep these pin assignments unchanged throughout the entire project. Open Tinkercad and choose Circuits. Create a new project. The center is your workspace for building the circuit. Place the Arduino on the left and the breadboard on the right. Leave enough space between them for clear wiring. The Arduino Uno is the controller. It runs the program and sends signals through its numbered digital output pins. The breadboard allows us to connect components without soldering. Keep it aligned with the Arduino for easy visibility. Add 3 LEDs in the order red, orange, and green. Place each LED leg in different connected breadboard rows. The longer leg is the anode, or positive side. The shorter leg is the cathode, or negative side. Add 1 resistor in series with each LED. The resistor limits current and protects the LED from burning out. Connect the red LED positive side to pin 4. Pin 4 will send high to turn the red LED on. Connect the orange LED positive side to pin 3. Use an orange or yellow wire for easy identification. Connect the green LED positive side to pin 2. The signal assignments are now red on 4, orange on 3, and green on 2. Connect each LED negative side through its resistor to the shared ground path, then to a GND pin on the Arduino. Check the wiring before coding. Red must connect to pin 4, orange to pin 3, and green to pin 2. Open the code panel and choose block coding. The Arduino reads the blocks from top to bottom in a sequence. High sets a digital pin to the on state, while LOW sets the pin to 0 volts, turning the LED off. Place the traffic light commands inside the forever loop so the Arduino repeats the sequence continuously. Set pin 4 to high to turn the red LED on. Add a 5-second wait. Then set pin 4 to LOW. Set pin 3 to high to turn the orange LED on. Wait for 1 second. Then set pin 3 to LOW. Set pin 2 to high to turn the green LED on. Wait for 5 seconds, then set pin 2 to LOW. The loop should read, pin 4 high, wait 5 seconds, pin 4 LOW, then repeat for orange and green. In text code, setup configures the pins as outputs. Setup runs only once when the Arduino first starts. Use digital write 4 high and delay 5000. Repeat with pin 3 and delay 1000, followed by pin 2 and delay 5000. Arduino text code measures delays in milliseconds. 1000 milliseconds equals exactly 1 second of time. Start the simulation. Red should turn on for 5 seconds, then orange for 1, then green for 5. Only 1 LED should be on during each stage. If 2 LEDs remain on, check your LOW commands. If an LED remains off, check its direction, breadboard row, resistor, and ground connection. If the wrong LED turns on, compare the code with the wiring to ensure pins match the block commands. To create a common streetlight sequence, arrange the blocks as green, orange, and red in the loop. Experiment with different timing values. Set green to 8 seconds or red to 3 seconds to see the change. To make orange blink, set pin 3 high, wait half a second, set pin 3 LOW, and wait half a second again. The project uses pin 4 for red, pin 3 for orange, and pin 2 for green. Everything is now connected. Your Arduino Uno traffic light is complete. Save the Tinkercad project to keep your work for later. You can now change the order, adjust the timing, or extend the circuit with more lights and signals. Start by dragging the Arduino Uno onto your workspace. Ensure it is positioned on the left side of the screen. Next, drag the breadboard onto the workspace, placing it neatly to the right of the Arduino. Now, locate the LED components in the menu. Select the red LED and place it on the breadboard. Repeat this for the orange LED, placing it in the next available row on the breadboard. Finally, add the green LED to the third row, ensuring all three are aligned horizontally. Take a moment to inspect the legs of each LED to ensure they are properly seated in the breadboard holes. Select the resistor component. Drag one to the breadboard for each LED to ensure proper current flow. Connect the first resistor to the cathode of the red LED, linking it to the ground rail. Connect the second resistor to the orange LED cathode, ensuring it also links to the ground rail. Connect the third resistor to the green LED cathode, completing the path to the ground rail. Now, use the wiring tool to connect the red LED anode to digital pin 4 on the Arduino. Use the wiring tool again to connect the orange LED anode to digital pin 3 on the Arduino. Finally, connect the green LED anode to digital pin 2 on the Arduino using a green wire. Double check that all wires are securely connected to the correct pins and breadboard rows. Open the code editor and switch to the block-based interface to begin your programming logic. Drag the Set Pin block into the Forever loop and select pin 4, setting it to the high state. Add a Wait block and set it to 5 seconds to keep the red light active. Add another Set Pin block for pin 4, but this time set it to the LOW state. Continue adding similar blocks for the orange and green LEDs to complete the full cycle. Once the code is finished, click the Start button to watch your traffic light simulation come to life.